Hi everyone, welcome to my channel. In this video, I will be explaining how to design input gated agents in LangGraph. So what it essentially means is that when we are developing an agent, in some kind of agents, the agent might require certain kind of information from the user before proceeding with the conversation. Like if that information is not available to the agent, it will not be able to answer the questions. So to explain or illustrate that capability, I have set up an agent around a uh, example where the agent will answer questions related to the vacation planning that the user wants to do. So for planning a vacation or answering any questions related to that, the agent will first require these three information: destination, the budget that the user has. Here I've kept USD, but we can have any currency if we want, and the duration in number of days. So these three information should be the first things that the user should answer, and after that only he should ask a question. Or like if he has asked a question already, but the agent should keep insisting on completing this information first and then answer the question. Otherwise the answer might not make full sense. So let me try to run this and show how it really works. So let's say the user says, I want to go to Goa for 3 days. Okay. So here, the first step the agent will do is that it will try to extract the information from the user's input. So the information that it wants to extract is these three essentially. So the destination that the user wants to go to, the budget it wants to extract, but right now the user has not provided, and the number of days. Okay. One more thing that we can optionally extract is that does the user has a specific question, or he just want a plan around the vacation. So if it just does not have a specific question, then the agent will by default create a plan. If he has a specific question, then that question will be answered. So here as an output, you will see that this information agent ran. Then after that, it said that the budget is missing. Please share that information before proceeding. So now if the user still does not answer this question, then let's say, how are you? So here also the answer is still not answered, right? So this can be an infinite loop, but this has to be answered before the bot can proceed. So this will work as a gate where unless all these three mandatory information are answered, the bot will not proceed further. Okay, it will keep asking for the budget. And in this process, the user has an option to change this information also, and like add the specific question also. So here the question, this is also a question, so this has been captured, but we can change it also. Let's say now I ask uh, what specific options are there for kids? My budget is $1,000. Okay. So if I put this, again the extract information agent will run. So here you can see that the answer is already generated. Why it is generated, I'll tell you. So here these three mandatory information are already answered. Destination is Goa, extracted budget is 1,000, extracted days is 3, and the specific question also is extracted, which is optional. But here this is extracted that what specific options are there for kids. So now it is answering based on the information, it is answering for the kids only. So after this, I can interact with the bot with this information, where the bot will keep this information always in mind, that this is what I want to revolve around. So now if I say, uh, how is the weather in Feb? So now if you will see that the bot already remembers that you want to go to Goa for 3 days, and uh, 1,000 is your budget. Okay, so all three information it remembers, and it is telling you that February, pleasant weather, and all of that. So it is able to answer. So this is a way of designing a gated uh, agent, where the agent will proceed only after getting certain information mandatory. So this is just an example, but it can be applicable to a lot of use cases. So yeah, so now I will try to walk you through. First, I will show you how the graph looks like in form of an image, and then I will quickly walk you through the code both the graph code as well as the chainlet code, what I have written in the chainlet code to explain how this really works. Okay, so first I will show you how this graph looks like, how the design looks like. So as a first step only, it will try to check that whether it should go to this direction, whether it should check the inputs and try to extract information from the user's query or user's input, or whether it should go in this direction where it will assume that all the information is already extracted and it will directly send the query to LLM response node. Here, once the extract info node is running, it will check whether all the three mandatory information is extracted from the user query or not. If it is not extracted, then it will go to missing info node and it will try to generate a message which will tell that please provide this missing information. If the information is extracted already, then it will go here only. So in these both cases, it will go to LLM and try to answer the user question because the information is already extracted. This will be the kind of an infinite loop where the user will be able to proceed in this direction only when they have provided all the information. Okay, so this is my design. I will show you in the code how this design really works. Okay, so I have just done the mandatory imports. I have initialized my LLM. So here also I'm using a free LLM from Grok API, Grok Online. Okay, Llama 3.3 70 billion versatile. Okay, now we define the state of the agent. State is that the fields that I'm using in the state is first is user query, what is the input coming from the user, then question state. Okay, whether the question's current state is inputs or query, like you see in this image, whether it is this or this. Okay, so this will be saved here. Then extracted destination, budget, days. These are mandatory information, and extracted user query if at all it is specific to the planning vacation planning that they want to do. Otherwise, it will simply generate the a plan of vacation. Okay, so missing fields like when the information is extracted, what all out of this three is missing will be saved here. Based on this only, we will decide whether to go to this direction or this direction. Okay, so these and the response. So the final response coming from the bot will be saved in the this field. Okay. Now the nodes. First is extract info node. So this is the Pydantic class that I'm setting because here I will be using LLM with structured output. So I want to extract information from the user is destination, budget, days, and user query. All of these will be optional because the user might not have provided this information, right? So yeah, this is the prompt that you are an information extraction agent. Extract below fields from the user query. Destination, budget, days, and user query. User query is only extracted when it is a specific question related to travel plan and without this information. So this information should be removed from the user query while saving this. Okay. Okay, let me wrap it so that you can see it properly. And it all of them should be null if they are not provided. Okay. So if you see here, all of these are optional. So they will be saved as null if the information is not extracted by the bot. Now, just to invoke sending this prompt in the system message and user query in the human message class. Now I will set up these variables. So these variables will be that the value will be coming from here if at all it is available, if at all it is not none. Otherwise, it should come from the state of extracted destination or none. What it means is that, let's say, for example, this information extraction node is running for the second or the third question. So chances are that destination the user might have already provided. Okay, so these are the two things which are missing right now. So in that case, the output of this LLM will not give the extracted destination because the user did not provide it again, right? So in that case, this will be none. But if it is already extracted, it will be present in the state, right? If in the state also it is not present, then it will be set up as none. Sorry. Otherwise, it will be reused. So the same rule we have applied for all of them. That like if it is from the state, it is already saved, then it should take it from there. Otherwise, it should try to use it from the uh, LLM output. So the reason I'm set it up like this is that the chances are that the destination was already provided in the previous input, but in the current input also the user again provided the input, so that has to be overwritten. Like in the first input, let's say he said that I want to go to Goa, but in the next input he said no, I want to go to Shimla. Okay, so then the Shimla should be the value which should be saved. So this will always be given higher priority compared to this. This will be used only if nothing is provided currently, right? And then it will try to see that what all missing values are there. So based on whatever values we have extracted here, so if any of these values are none, then we will add those values to this missing list. So if extracted destination is none ultimately, then it should be added to this list, budget, days. Okay. So then, yeah, so these are the information that we have extracted. And then what we will return? We will return the user query. We will return the extracted destination. It can be null also. It can be an extracted value also. And yeah, so why I have set up this dictionary is that I want to set these values to the user session of Chainlet. So because that if in a previous question the user has already provided this information or this information, for example, then it should be available in the session. Otherwise, we will not be able to reuse that information because we are running it from the scratch for every query and the state is reset all the time, right? So this will we will save in the user session and we will provide this information as a initial state every time. So when the user is asking the first question, all these values will be null or we will not provide it, right? So in the final output, we are sending extracted destination, budget, days, user query, and missing fields. Okay. So now we have created a conditional router where it will check whether all the required information is provided. If the length of missing fields is zero, like if nothing is missing, then it will take to information complete. Otherwise, so like if the length is greater than zero, like even one value is missing, then it will say that the information is incomplete. So this router will work here. Okay. Either it is incomplete. Incomplete means that the missing info node will be triggered. If it is complete, then it will take it to the LLM response node. So now missing info node, it will simply say that we will take the missing fields from the state and the final response that will go to the user is missing. Please share this information. So simply whatever fields are captured in the missing fields list, we will simply convert them into a string and we will tell that, okay, this information is missing. Please provide this. Okay. Then state check node will be the first node that will be executed. Here it will check that what is the question state. If it is inputs, then it will return inputs. Otherwise it will return query. So this value will always be provided in the initial state. Okay, I will tell you how this whole thing works. Now LLM response node is rather straightforward. It will execute only when all the information is extracted. So these are all the information. You are just telling that you are a travel planning assistant based on user's query and provided details, provide answer to user query. Okay. So here the user query, which will be extracted user query. Okay. So here I'm writing that if user query is missing, then give a comprehensive travel plan. Okay. So if user has not asked any specific question, then it will generate a comprehensive travel plan only. And these are the fields that were extracted. So whenever this node is running, this information will always be used as a context. Like in every answer, it will already know that you want which destination you have chosen, what is your budget and how many number of days. So for that reason, in every answer it will take a like a reference of that and generate a response accordingly only. Here we are using a simple LLM because we just want a string output. Okay. And then we are just returning the final response dot content. Okay. Now we have just built our graph. We initialize it with the agent state that we have defined. We define these three nodes: extract info node, missing info node, LLM response node. Here you can see one, two, three nodes. Then we are using adding a conditional edge. From start only, it will use this conditional router, which is state check. If it is inputs, then it should go to extract info node. If it is query, then it should go to LLM response node. Okay, so here I think one more thing I've done is this, right? So this I think I missed to explain. So what it will do is that if at this point it is checking that what all information is extracted already. If all the information is extracted, which means nothing is missing, then in the state user session, it will save this value as query. That means that in the initial state provided for every question, it will be changed to query. Otherwise, it will be input. Okay. So from Chainlit, we are using this user session where for the particular session, some value is retained and reused every time. Okay, so this is also yet another information that will be reused. Now, another conditional router, which will start from extract info node. Extract info node, it will check whether the information is incomplete or complete. If it is incomplete, it will go to missing info node, which will simply tell this information is missing, please provide that. If it is complete, it will take it to LLM response node, which will just generate the output. Okay. Now, both these nodes are the last nodes, so they should be connected to the end of the flow. Now we just simply compile it, and optionally we can save it in the image also, which I've shown here. Okay, and then we return the compiled graph. So here this class we will just import this method we will import in the chainlit app.py, which will be the final file which will be run as an application. Okay, so what this is doing, I'll explain that as well. So here we are just doing the simple imports. Graph, we have simply imported this, right? From the graph.py, we imported this method build graph, and then we are just saving it in this variable. Okay, so this is a compiled graph. Now in chainlit, on message means whenever a user sends an input, then this method will be called. Okay, so now this is just a function that we have defined. The messages will come from cl.message. User will input will be message.content. Okay, this is the input coming from the user. Now we will check what is the question state. So in the user session, we will check whether this variable is available or not. We are using get because chances are that this might not be available in the user session, because when we are asking the first question, this is not available. So then in that case, the default value should always be inputs. Okay. And this will remain inputs until all the information is already provided by the user. Now the initial state we will set up. So here also the session state we are saving. So session state, I will tell you where we are saving it and how. Yeah. So this is the session state we are saving during the run. So by default, it will be blank. But if the a flow has already run once or twice, then the session state will always be available. And this should be the initial state, which will contain this information, which should be reused. Okay. Then what should be the question state? That should this value should also go to the initial state, which we have extracted from the user session. This should be also be there. Now, if the question state is equal to inputs, then the user query will be user input only. Otherwise, this should be saved as an extracted user query. Why? Because if it is inputs, if it is a query, that means all the information is extracted. Now, every time the query will go to the LLM only. And in LLM node, we are not using the user input, we are rather using the extracted user query. So now after the information is extracted, like for example here, how is the weather in web? So this came as a user input, but it will be answered using the extracted user input or user query. So this should be saved in this. If the question state is set to query, okay, then simply async for node output in graph. So we are just streaming it. So for this reason only, we are able to see this every step. Okay. So this part we are able to see only because we are streaming it. So in streaming, it will provide updates and every step will be sent to the Chainlit UI. Okay. So whatever output comes from the first step, it will be saved in form of a dictionary. If the step dictionary contains this extract info node, then it should send this as a step rather than sending as an output, a message. So step here, the input is this. If you can see here, this is the input, which is the user query. Okay. And the output is whatever extract info node the output is coming. It should be converted into a JSON string and sent as an output. So this will be the output. Okay. So this will rather be displayed as a step rather than just a message. Okay. If it is missing info node, then also it will go as a message. It is if it is a LLM response node, then also it will go as a message. Okay. So now this is very straightforward. It is a chainlet standard way of displaying the output and taking the input. So yeah, so this is about creating gated agents in LangGraph. So this can be used in or many use cases. If you have a complex use case in mind where you want to implement this, please let me know in comments, and I'll try to help you implement that for you if you are facing some issues. Otherwise, please let me know in comments what other videos you would like to see around AI and LangGraph. Thank you for watching my video. Please subscribe to my channel to watch more advanced concepts around AI and LangGraph in general. Thank you. Bye.